This is confidence intervals to find the mean when the population standard deviation is known, part 3. We're picking up with example 5. A machine that fills cereal boxes is supposed to put 20 ounces of cereal in each box. A simple random sample of 6 boxes is found to contain a sample mean of 20.25 ounces of cereal. It is known from past experience that fill weights are normally distributed with a standard deviation of 0.2 ounces. Construct a 92% confidence interval for the mean fill weight. So for the confidence interval, first we need to check to make sure that the sample size is big enough. So the sample size is 6. So that's not bigger than 30. So if that's the case, check to make sure it says it's normally distributed. And it does. So if that's the case, check to see what we are constructing a confidence interval for. We are constructing one to estimate the mean fill weight. So we want to find the mean. So let's look and see what kind of standard deviation we know. It is known from past experience that fill weights are normally distributed with a standard deviation of 0.2 ounces. Is this the sample mean? The sample standard deviation or the population standard deviation? Well, this is not from this sample of 6 boxes, it's from past experience. So this 0.2 must be a population standard deviation. And because that's the case, we can use the formula we got in the previous video. So x bar, which is our point estimate, plus or minus the margin of error, and the margin of error is our critical value, times the standard error, which is the standard deviation over the square root of n. So let's write over here what we know. We know that x bar is the sample mean, which is 20.25 ounces. We need to find our critical value. We don't know what that is. What we do know is that our confidence level is 92%. So we can use that to find our critical value. So 92%, that's the center of our curve there. So if 92 is in the middle, that means there's 8% on either side, because the whole thing has to add up to be 100%. So that means this side is 4% and this side is 4%. So to find this number right here, which is our z, it is INV norm. Area to the left is 0.04. Remember, this particular thing is for the standard normal curve. And so we get negative 1.751, which we will knock the negative off. We just need the answer without the negative, 1.751. And then what else do we have? We have our sigma, our standard deviation, which is 0.2 ounces. So for filling this in, we have 20.25 plus or minus 1.751 times 0.2 over the square root of n. N is the sample size, which is 6 boxes. So we put 6 here. So you're going to do this twice. The first time you're going to do it with the subtraction sign. You're going to do 20.25 minus 1.751 times 0.2 divided by the square root of 6. And we get 20.107. Now, for this, I would round it like I would do the mean. So in this, since we're estimating the mean, so I would go out one place past what the sample mean was. So 20.107. If we change it up and make it plus instead, 20.25 plus 1.751 times 0.2 over the square root of 6, we get 20.3929, which rounds to 393. Now, when we finish this, we have to write our answer in the correct format, and we also need to write our answer in a sentence. So first, there's a couple ways that you can write a confidence interval. So one, you can just put it in parentheses and sort of write it like an ordered pair, with the first number being your lower boundary and your second number being your upper boundary, like that. You can also write it, the lower boundary is less than the parameter, in this case the mean, which is less than the upper boundary. So you can write it either way, in interval notation, or you can write it in inequality notation like that. But it will also ask you to interpret your answer in a sentence. So the sentence basically goes like this: we, or I am, or we are, and then you're going to put in your confidence level. In this case, we are 92% confident that the true, what are we finding? We are estimating the mean fill weight. So the true mean fill weight of the cereal boxes is between 20.107 ounces and 20.393 ounces. So basically you could use this as a template. So the things you need to change up would be the confidence level, the context of what we're finding here. You're estimating what? In this case, it's the mean fill weight of the cereal boxes. And then obviously you would change the actual confidence interval numbers. Right? So for example 6, we're going to estimate the confidence interval for SAT scores using a 99% confidence interval. So pause the video, use the same formula we used before, and come back and see if you got the right answer. Okay, so this time we have 100 entering freshmen as our sample. So that sample is big enough. So it doesn't matter that it doesn't say that it is a normal distribution. Let's read the whole thing just in case I missed that somewhere. A college admission officer takes a simple random sample of 100 entering freshmen and computes their mean mathematics SAT score to be 458. Assume the population standard deviation is 116. Construct a 99% confidence interval for the population mean score. So it doesn't say it's a normal distribution, but the sample size is big enough. It is bigger than 30, so it makes up for it. So remember, here's the formula that we use when we're looking for a confidence interval for a mean, and we know the population standard deviation. So let's check and make sure we know the population standard deviation. It says assume the population standard deviation is 116, so we're good there. So let's write all the things we know, and the things that we need to know. Okay, X bar is 458, and Z, well, let's calculate it. So the center is the confidence interval, which is, or I'm sorry, the confidence level, which is 0.99. That leaves 1%. 99% is the middle. That leaves 1% on either side, so that leaves 0.5% on the left and 0.5% on the right. 0.5% is really 0.005 as a decimal. So we're going to, for our z, we're going to do INV norm 0.05. I'm sorry, 0.00501. So let's calculate that in our calculators. You will type in second bars, choose number 3, put in 0.00501, and we get negative 2.576, but we're going to drop the negative off, and the number of the sample size is 100. So now we're just going to fill in the blanks. X bar is 458 plus or minus z. Oops, just realized I did that there. Our z was 2.576. Our sigma is 116. Sorry about that. So z is 2.576 times sigma, which is 116, over the square root of 100. So if I type that in my calculator and I do 458 minus 2.576 times 116 over the square root of 100, we get 428.118, and if we add it instead, we get 487.882. In this case, you need to round to at least one decimal place. This is a whole number. If you go one place past that, that'd be one decimal place. You get 428.1 and 487.9. So at least round to 1. I rounded to 3. So let's say you can write it like this, the two together like that, or you can write it like this. 428.118 is less than the mean, which is less than 487.882. And then for our sentence, we would say we are 99% confident that the true mean mathematics SAT score is between 428.118 and 487.882. And again, you can use this as a template. Just make sure you change the confidence level, the parameter you're looking for. Make sure to use the context of the problem. Don't just say the true mean is between, what mean are we finding, and then the actual confidence interval boundaries. Okay, so we're going to stop the video here and pick up with example 7 in part 4.